This is a demonstration of the Forest Manufacturing Model 2054 vertical blade traveling table bandsaw. This is our big vertical blade machine. Obviously from the name, vertical blade. We're looking to saw from a temporary front end, and I'll explain that in a minute. Anyway, vertical blade, traveling table mounted on rollers. The table has a variable speed powered traveling mechanism. Blades, this thing can carry up to a 1-inch blade, in some cases 1 1/4-inch blades. Blade speed is fixed at about 3,000 feet per minute, suitable for cutting woods, plastics, foams, insulations, or today, big plastic boxes. Pneumatic tensioning system. Since this is what would normally be the back of the saw, you can see all the tensioning mechanism up here. Air tension cylinder, blade breakage switch, works by measuring a full stroke out of the cylinder. Electric solenoid valve, air pressure control, air pressure switch. If you don't have enough air pressure, the machine won't cut. A quick explanation of what you're looking at here. This is normally what we think of as the back of the saw. The customer for this application, though, has an existing process line, and to fit in with what he's doing, it made sense to make this the front of the saw. So we have the machine set up to cut from this side. So the workpiece is right now in front of the blade. Table will go that way to make a cut. The blade cabinets, or the wheel cabinets, open to the opposite side. Normally open to the front. This machine we're calling it the back. It's a little messed up, but it works for the customer's application. So, vertical blade, traveling table. Machine has what we call our basic controls, although they aren't really all that basic. For the saw blade motor, simple start and stop. We have a magnetic motor starter with an overload. This machine has a 5-horsepower blade drive motor running at a fixed speed of about 3,000 feet per minute for the blade speed. Pneumatic tensioning controlled here, tension, detention. You cannot start the blade motor if the blade is in the detention position, or if the blade is broken, or if you have insufficient air pressure. That will prohibit you from running the blade motor. We have table controls, table forward button, table reverse button, table stop. We have separate potentiometers for the forward and reverse speeds. What will normally happen is the operator will find some cutting speed for the table that works for them. We like to set up such as in the range of 10-20% of full speed. So they'll find that magic speed that cuts as fast as they can without screwing up a quality cut. And they'll want to leave the potentiometer set there. But at the end of a cut, when you're moving back to the home position to reset for the next cut, you want to move as fast as possible. So we have a separate potentiometer for the reverse speed. And normally you're just going to leave it at wide full throttle, 100% speed. This machine also has a laser. It's a laser line projector. Shows where on the workpiece you're going to make the cut. And a quirk we just discovered, you can see it here on my hand, that'll show where it's going to cut. Now this customer's workpiece, this is the first time I've cut this specific workpiece, and where the laser mounts over here is kind of in the way. It actually mounts a little higher than this, but still, all the good information is on the back side. So what we're doing with this machine is we have a separate workpiece positioning fence crank on the back side. So if you're trying to line the laser up on a rib or a mark or whatever, you can turn the crank on the back side to shift the workpiece. So laser on, laser off. In the event of a power off, everything just stays off. It has a safe power off system. Have a couple of indicator lamps here for fault conditions. Motor fault. If the blade drive motor or the table drive motor have a fault condition, whatever that might be, red light. And if you have a blade fault, either because the blade breaks or you lose sufficient air pressure, or if the blade is in the detention position, fault light. So this machine has our workpiece positioning fence. On big machines like this, we use an extra stout version of it where the mounting, and this is normally covered by guards, we're letting you see it today. The mounting block here is extra wide. Normally this is about a 4.5-inch wide block. For these big machines, big workpieces, big fences, we use a 6-inch wide block. Just, better, a little stiffer fence. 3/8 inch aluminum mill plate as the fence face. No one's going to argue with anything other than flat, and we reinforce it on the backside with aluminum angles. Now, I normally tell people that the workpiece positioning fences used to be as a gauge or a stop. Use the electronic digital readout to move the fence where you need it, read the number, set it where you need it, lock it down. And I normally tell people not to try to use the fence to move the workpiece, but you can get away with it. So it will shift the workpiece, requires 2 hands to do it, but it'll do it. Not really how we intend it to be used. People do it anyway. Worst case is you wear out the gears a little faster. So this is a big, heavy workpiece, more than I expected. But we can just crank that to get the cut we want. This is an interesting box. It's a collapsible box. We haven't set it up right. We're going to just try to cut through. We'll cut through about here. This is one of the hinge points right here. That's probably one of the tougher things. So that is kind of nice to be able to do that. Let me take a quick peek at what the laser's showing me. Yeah, that'll go right through that hinge point. So, cutting boxes, I'll start the cut in a moment here by explaining a little detail. Cutting through boxes like this, a little bit of a pain in the butt because you've got a solid wall of plastic here this tall. That's going to want to cut fairly slowly. When we're in the middle of the box, we're only cutting through about yay much plastic at the bottom. So we'll cut very slowly to break through this wall. Then I'll be able to go quickly through the meat of the workpiece here, which is actually just a plain bottom. Then I'll have to slow down when I cut through the other wall. I will shift the position of the camera to give you a little better view of what's going on. Going that way. And the power of zoom. You won't be able to see me operating the machine, but that's not really what you're here for anyway. Another note, oftentimes I suggest people put some kind of a work stop here to keep the workpiece from pushing back. This thing's pretty heavy, it's got a pretty high coefficient of friction. It's not going to be easily moving, so I'm not even going to bother. I don't think we need to. So I start the saw. Well, first I check we're tensioned. We are. Start the saw blade. I'm going to start off with the table drive speed at its minimum setting. Start the table forward. I will speed a little bit to get close to the blade. And then I'm going to slow down to a creepy slow speed to break through that wall. I'm operating here from the panel face. We do offer a remote control pennant for these machines. This customer did not specify that. Slow is actually really pretty slow. Sneaking up on the workpiece, I know. It's like watching paint dry right now. Okay, starting to bite in. Oh, it's taking that, no trouble at all. Okay, it's through the ribs now. It's into the actual face of the inside of the box. So this is where it'll be cutting through the greatest amount of plastic. Oh, that's gravy. Okay, it's into the inside of the box now. I can speed it up. Seem to mind that at all. Okay, we're approaching the second face. Same deal, I'm going to sneak up on it slowly. About its slowest speed there. Speed range is about 50 to 1, 40 to 1, 50 to 1. Okay, just starting to kiss that. You'll be able to see a breakthrough from this side. Just starting to kiss that wall. I wonder if there's metal in those hinge pins. This thing's making sparks at that hinge pin. I wonder if there's metal in there. And we're through. This automatically shuts the table drive off. Let's see what we got. That looks the business. Let's flip it over flat side down. Let's see here. The power of telephoto.
And show them the cut edge.
Nice. No trouble at all. This is kind of funny. I'm going to, actually I did really, really well. I didn't plan this. Pardon the shaky cam, folks. I want to zoom in on something here. So I could have planned this on the inside grid here. We were cutting through, we were just kissing one of these ribs. Had I been planning a little better, I either would have cut through the middle of the rib or avoided it entirely. Just kissing a rib like that is actually pretty tough. It wants to be, when you try to just cut the edge of something, the blade often wants to track out of it. Tracked in it just fine. And that's what it does. That's a Forest Manufacturing Model 2054, great at cutting up big boxes.